Welcome back. We're going to discuss an exercise that has to do with inverting, computing the inverse of a matrix, but in a very specific manner because the matrix has numbers, has numeric entries in almost every entry, but one entry. So there is one entry here that has um, something expressed as an unknown or as a variable. It has something expressed as a parameter, if you will. And then we have to undergo the calculation to determine what values of this parameter would make this matrix be of a certain way. Remember that here the word invertible means the matrix has an inverse, but you will find that having an inverse is also equivalent to being non-singular, right? So non-singular matrices are called non-singular because the only element of their null space is the trivial vector, the vector of zeros. But also these matrices have the equivalent property of having an inverse. Okay, so let's read the exercise. And so we can see here that the exercise says find the values of k for which this matrix has an inverse, for which this matrix is invertible. So what we do is that we go ahead and calculate the inverse of the matrix, and for this we use that method that says that you would form an augmented matrix and would row reduce this augmented matrix. So here is the first block of the rectangular matrix where we would put this there. On the second block, we would write the identity. So first column 1, 0, second column 0, 1. Okay, and so now we have this rectangular matrix and we undergo the operations of row reduction because our goal is to make this, that's what we're aiming for. We would like to row reduce this rectangular matrix and we would like this block to be the identity matrix. So the first operation we perform here is we want to create a 1 on the 1, 1 entry of the matrix. So we divide row 1 by 5 or multiply row 1 by 1/5, and that gives us a first row that has these values. Second row is looking at the moment exactly the same. Okay, so now I'm going to write here on the next line what corresponds. Our goal would be to create a 0 on entry 2, 1. So what we do next is to multiply row 1 by 4 and add that to row 2. Okay, multiply this row by 4 and then add that new row to the second row. And so that gives us a 0 on entry 2, 1. Then we end up with this expression for entry 2, 2, and then in entry 2, 3 we have 4/5, and in the entry 2, 4 we have a 1. So here is where we have to relate to the what this question is asking, and we have to relate in the following way because we want to find values for which values of k for which there is an inverse. So to continue with this calculation, what we would need to do is to create a 1 on this position, right? And to create a 1, whatever expression we have there, what we would do next is to divide by that number. So the key here is to realize that that number, in order for us to divide and still have a number, we have to, the requirement is that this number is different from 0. It doesn't matter what it is. In general, we're operating under the assumption this number is a complex number. So it doesn't matter what it is. Okay? In general, that is a complex number, but what we need it is to be a complex number different from the origin, different from 0. So maybe I tried that. What do we need? We need, so this is our requirement. We need that entry to be different from 0 so that we can divide by that non-zero number, that entire row. That would give us a 1 there, and then it's easy to create a 0, and then we would be, would be finished. So we have this requirement. We need this entry different from 0. So to investigate this further, what we do is we're going to do the following. We're going to say, you know what? We're going to solve an equation. We're going to solve the equation. So we're going to solve the equation minus 8 over 5 plus k equal to 0. We're solving that equation for k because that is the symbol here we use for the unknown. And this is a simple equation to solve. Turns out if k equals positive 8 divided by 5, then if k equals this number, that expression is 0. So what we need to do is that the answer to this question would be that if k is not 8 over 5, then the inverse of the matrix we're investigating, this inverse, exists. Okay, and that's exactly what we wanted. So we wanted an answer of that type. We have found the value that makes the matrix. In other words, if k equals this value, maybe I can go backwards here. If k equals that value, this entry would be 0, and you would have two zeros over there, a row of zeros for the first block, and that would tell you the matrix is not invertible. Okay, so when k equals that value, the matrix does not have an inverse. It also means the matrix is singular. So by saying that k different from 8 over 5 or whatever the value is, this really means that you are given not just specific value, you're given an interval value. So if you assume that k is a real number, so you could write this expression in interval notation. But okay, so that would be one way of going about this type of exercise. Thank you.